Let's see some options. So Yersinia -H or -H. We've got G for graphical mode. So let's use that. So Yersinia -G or -G. Now we're told that this is an alpha version. I'm not going to worry about that. I'm going to run it anyway. And let's click Launch Attack and again go to DTP. On the switch, show interface trunk. No trunks at the moment. The trunk is timed out, so let's send DTP packets again. Show interface trunk. Notice it's now become a trunk. The nice thing about the graphical user interface is that you can see what's going on more easily, and you can also see a log of what's happening. So you can actually see if an attack finished or not. So if we go launch attack, DTP, we can send DTP packets, we can enable trunking, and notice trunking is once again enabled on the switch. It's as simple as that once again to get trunking enabled. So let's go to VTP. Let's launch an attack. We're going to send a VTP message. We can see once again in the log what's going on. And we can see that messages have been received from the switch. But let's delete a VLAN again. So on the switch, show VLAN brief. We have various VLANs configured. Let's delete VLAN 3. So delete a VLAN, click OK. I'm going to delete VLAN 3. Now notice the attack has been born, but the VLAN still exists. So to kick it into action, I'm going to say VLAN 7, and I'm going to create a VLAN here. Notice something's happened now. We can see that the attack is finished. VLAN got it. And if we go back and look at the VLANs, notice VLAN 3 is now missing. Launch an attack again. Let's go to VTP, delete a single VLAN, and in this case I'll delete, say, VLAN 5, which is currently on the switch. So VLAN 5 is there. I'll create VLAN 8. Click OK. When I type exit here, it generates traffic, and Yersinia can more quickly get things done. So show VLAN brief. Notice VLAN 5 is missing from the VLAN database. That doesn't really affect hosts on the network, but notice these ports are in VLAN 2. And the important one to take note of is gigabit 02, this port. At the moment, this victim PC has this IP address and should be able to ping the router. That's the IP address of the router. I can verify that by using show IP interface brief. Notice IP address of the router, debug IP ICMP. The router is receiving ICMP messages from the PC. So the PC can currently ping the router. But what happens when we delete a VLAN 2? That PC is in VLAN 2 on gigabit 02. This is the VLAN that the port is configured in. What happens when we delete the VLAN from the VLAN database? What should happen is the PC should be taken off the network. So let's see if that works. I'm going to launch an attack again. VTP, delete a single VLAN. Now notice here the sequence numbers are increasing as the pings carry on. But let's see what happens when I delete a VLAN. I'm going to delete a VLAN 2. Pings are still carrying on. I'll create another VLAN, let's say 20, on the switch, and let's see what happens. And notice the pings are failing from the PC to the router. They stuck at sequence number 87. Show VLAN brief on the switch. Notice VLAN 2 is now missing from the VLAN database. I've essentially taken this PC off the network. Now to prove it again, let's add that VLAN back. So I'll add VLAN 2 back to the network. So hack 2, click OK. That's going to start the attack. So on the switch to speed things up, I'll create another VLAN, let's say 21. Notice the attack is finished. Over here, show VLAN brief. We've got VLAN 2 back in the database. This port is in VLAN 2. So what should happen is after a while, the pings should succeed. If they don't, I'll restart the pings. But there you go. Just took it a while for spanning tree to converge. And there you go, the pings are continuing. So that port is in VLAN 2, pings are working. Show interface gigabit 02 switch port. Notice the VLAN is this one. But let's remove it once again and see what the interface looks like. So VTP, delete a VLAN. VLAN 2 will be deleted. Pings are still carrying on. Again, I'll do something on the switch to initiate traffic. So I'll say no VLAN 21. Delete one of the VLANs we created. Notice the pings have stopped on VLAN 2. So show VLAN brief. VLAN 21 is deleted. That was the one I created manually on the switch. Notice VLAN 2 is also missing. So show interface gigabit 02 switch port. Notice we told that the VLAN is inactive. This port gigabit 02 is in VLAN 2, but the VLAN is inactive. So the port is essentially shut down. So the port is not available for use by users. The user cannot access the network. So show VLAN brief once again. Notice the various VLANs in the VLAN database. But let's make it worse. Let's simply delete all VLANs. So I'm going to send that message to delete all the VLANs. Attack has been born. Show VLAN brief. We've still got all our VLANs, but let's say the user creates VLAN 50. Types exit to generate traffic. Notice the attack is now finished. Show VLAN brief. Notice all VLANs have been removed from the switch, except for the default VLANs. So VLAN 1, the default VLAN on Ethernet, FDDI VLAN, token ring VLANs are shown, but all other VLANs have been removed from the switch. To get them back, I'd have to manually create the VLANs. I'd have to manually create VLAN 2 or use VTP to advertise VLANs back to the switch from another switch. But as you can see here, VLAN 2 is created. This port is in VLAN 2. It'll take it a while, but hopefully that port will transition to the forwarding state. So if we go to VLAN 2, notice the port is in the learning state in spanning tree. So show spanning tree VLAN 2 now. Port has just transitioned to the forwarding state. So pings can now succeed. It's as simple as that to break networks using Yersinia. I've shown you an example using DTP and VTP.